kind of ignitions will come that may harm our eyes. So that's what. So what do you observe? What do we observe? We will observe it. The magnesium ribbon color was different and the ash color is different. It means there is a chemical reaction happening there. Okay. So let's see that how it is happening. See, this is a Bunsen burner. It is invented by a scientist named Bunsen. That's what it is called, Bunsen burner. There is a small magnesium ribbon. This is called tong. It is a holding device, and when magnesium ribbon is burnt in presence of burner, what will happen? The ash is being collected in a container. The color of the ash and the color of the magnesium ribbon is different. What is it indicated? Mg burns in presence of oxygen, so you are getting MgO, magnesium oxide. How we can see here? See, magnesium ribbon burns with dazzling white flame and change into a white color powder. Okay, then this powder is magnesium oxide. This white color powder is magnesium oxide. It is formed due to the reaction between magnesium and oxygen present. So let's write a reaction. How we will write? What are the reactants? Our reactants are magnesium and oxygen. When magnesium and oxygen combines, you get a white color powder, that is magnesium oxide. What is the appearance? White color powder. Okay, we can write it in the form of symbols also. If you are familiar with this symbol, magnesium symbol is Mg. So Mg plus O2 gives MgO. O2 is oxygen, MgO is magnesium oxide, okay, which is white color powder here. So this is the experiment. What did we observe in this experiment? We observed it, the change in color, change in appearance, change in, see, color and appearance also. Color is change as well as appearance. Here it is a kind of strip, ribbon kind. Here it is powder form, okay, as well as change in temperature. There are many activities. These are all called reactions, chemical reactions. So another activity is there. Here next experiment is there. You can observe it here. This is called test tube. Test tube is used in a test tube stand. It is kept and it is used always for doing a small quantity of chemicals. Reactions can be done in the lab and can be observed. So we can see, take lead nitrate solution in a test tube. In a test tube, lead nitrate solution is taken. Okay, suppose this is a lead nitrate solution. In that, potassium iodide solution is added. Suppose this solution is potassium iodide, which is added to this lead nitrate solution. What will we observe? What we will observe? We will have a reaction. We can write a reaction. Let's write a reaction. Lead nitrate plus potassium iodide. What we get? Lead nitrate plus potassium iodide. This kind of reactions are called double displacement reaction. We will study the type of reactions also. Just for your reference, your curiosity, I am telling this. This is double displacement. Double displacement means shifting of any of the component from one place to another. Double means at a time two components will displace. We can see here in lead nitrate, lead is one component, nitrate is another. In potassium iodide, potassium symbol K is one component, iodine I is another component. Now what will happen? Interchange will happen. See, one displacement is when Pb has gone and combined with I2. So you get one PbI2. Second displacement is when potassium combines with nitrate. So you are getting KNO3, potassium nitrate, like that. So twice we have a combination and two times bonds are breaking and the new bonds are forming. This kind of reactions are called double displacement reaction. So what we observed here? We observed it when lead nitrate combines with potassium nitrate in a test tube. We are getting the precipitate of lead iodide. Okay, we are showing the indicating the arrow downwards. Always you remember this, in a reaction we are using this kind of symbols and you should understand it. Whenever arrow upward is written means the gas is liberated. Okay, any gas is liberated because gaseous substances will try to go up because of the very less interparticle force of attraction and the light mass. Okay, so gas is liberated whenever we are writing arrow upwards. Whenever we are writing arrow downwards, it means precipitate. PPT means, here we are not talking PowerPoint presentation. PPT means precipitate. The short form for precipitate in chemistry is PPT. So we are showing arrow downwards. It means there is a precipitate. Why? Because when the experiments happens in a test tube, we will observe it at the bottom of the test tube. There will be some solid will separate out, and that is why the arrow downwards it is shown. Liquid state, there is no arrow or any indication, because when no arrow is indicated means substance is in, might be in the liquid state. Okay, so this liquid state or solid state also, this can be indicated gas liberates, and this indicated PPT appears. Okay, so we have to remember all these things, symbols. Now what do we observe when the reaction between, what kind of reaction happened? Lead nitrate. What was the reaction? Lead nitrate combined with potassium iodide. Okay, what did we observe? We observed the precipitate of lead iodide is obtained. Okay, precipitate means solid particles settle at the bottom. Lead iodide is obtained. Then another experiment is there. Take a few zinc granules in a conical flask. You can see here, this kind of flask is called conical flask. In this flask there is a zinc granules here at the bottom, then sulfuric acid is added on top, and glass tube is there with the cork. The rubber cork will be there which is closing the conical flask. Okay, and one hole cork is there. Cork can be one hole, two hole, depends on the requirement. One hole cork is there here for inserting one tube into that. So take a few zinc granules in a conical flask or a test tube. Add dilute hydrochloric acid or sulfuric acid. What we observed here? Here we have taken zinc granules, we added sulfuric acid or HCl. So let's see the reaction. When zinc reacts with sulfuric acid, we are getting zinc sulfate, and hydrogen gas is liberated. So what we can observe here? We are observing, see, molecules are, no chemical formula is written on the molecules. How will you observe what has been formed? We can see by the changes happening there. So when small bubbles started coming, it means hydrogen gas started bubbling up there. So gas is liberating in that process, and the appearance is changing. Zinc is converting into another color appearance when it converts to zinc sulfate. Okay, so here sulfuric acid is acting as an oxidizing agent, and this process is called redox reaction. Why? Because simultaneously reduction and oxidation, two activities are happening here. Reduction means there is gain of electron always, oxidation is loss of electron. So we will study in more detail. Just for your curiosity, we are writing the reaction here. So zinc reacts with sulfuric acid. Let us know the symbols also. Zinc symbol is Zn, plus sulfuric acid is H2SO4. When Zn combines with H2SO4, what will happen? The Zn part is combining with SO part. So ZnSO4, like that. This is very simple way of writing reaction. You can also write, always writing reaction means making and breaking of a new bonds. Okay, so ZnSO4 plus hydrogen gas is liberated. Now again, see, gas is liberated. We are showing arrow upwards in a reaction. I have just written the reaction for curiosity sake here. So add dilute hydrochloric acid or sulfuric acid. If we write with reaction with hydrochloric acid, we will show it here as zinc chloride, and hydrogen gas will liberate there also. Okay, so let's see next one. Do you observe anything happening around the zinc granules? What did we observe? Hydrogen gas bubbled. Okay, we can say, correct, na? Hydrogen gas bubbled. And appearance also change. Touch the conical flask in a or test tube. Is there any change in temperature? It is hot because the gas is exothermic and the process is exothermic, energy is liberated. So the temperature little increases. The conical flask is warm. Okay, then how we will follow the following observations to determine whether a chemical reaction has taken place. So if we observe this kind of changes, we will take an example of same experiment where zinc granules are treated with sulfuric acid. So what we observed? Change in state. Yes, because zinc granules converted to zinc sulfate. Then change in color. Zinc granules color was different than zinc sulfate. evolution of gas, hydrogen gas bubbled, okay, and change in temperature. Yes, flask was warm means the heat is liberated, like that. So all these observations, these are our observations, all these observations are indicating there is chemical reaction taken place, okay. So we can identify a reaction has taken place or not by these kind of changes. So as we observe the changes around us, we can see there is a large variety of chemical reactions taking place around us. So keep observing now. From now, whenever you are seeing this video, after that you keep observing around you whatever reactions are happening and what are the changes are happening. You try to learn from that. You will learn more and you will find it more interesting, because when you actually observe it, or when you do the small experiments at your level, but be careful, always precautions has to be taken, but apart from that you can observe it in your daily life, what are the chemical reactions happening around you, okay. And how to identify the reaction happened or not: change in color, change in state, change in temperature, everything you have to observe it carefully, okay. So let's see under that. Around us there are many activities which are happening constantly. There are different type of chemical reactions are constantly happening in our daily life, okay. So how we can write that in a form of equation? If we can write it at the transformations in a form of equation using a specific formula, that will be more easier, okay. So the transformation of a chemical substance into one another is known as chemical reaction. For example, we have seen in previous class one experiment where magnesium ribbon is burnt in presence of oxygen, which is converting to magnesium oxide. So word equation, we will write magnesium plus oxygen gives magnesium oxide. If word equation or the description, instead of that, if we know the formulas and if we directly write the formula in an equation, then the equation will be more condensed, more simplified form, okay. So same equation can be written as symbol for magnesium is Mg, symbol for oxygen is O2, and Mg and O2 combined to give magnesium oxide, MgO, okay. So now why we need to balance the equation? Why the number of atoms same should be there left hand side or reactant side as right hand side or product side? Because of law of conservation of mass. According to this, mass can be neither be created nor destroyed in a chemical reaction. It can only be changing one form to another form. Like if you are burning a paper, paper will be over. One form of mass is over, but same time it will be converting into ash. So it is converting into, transforming into another form. That is only law of conservation of mass, okay. So total mass of the element present in the product of a chemical reaction has to be equal to the total mass of element present in the reactant. So total mass which is present at the reactant side should be equals as product side. So that is only called balanced chemical equation. Equation must be balanced. Number of atoms used in a reaction should be number of atoms produced in a reaction, like that, okay. So in other words, the number of atoms of each element remains the same before and after a chemical reaction, okay. Like for example, if we say A plus B gives 2AB. So we can see here A is, there are one atom of A, 1 minute, A plus B gives AB. So there are one atom of A left hand side, reactant side, as well as one atom of A product side. B, one atom of B left hand side, reactant side, as well as one atom of B product side. But product is 1, reactants are 2, that doesn't matter, but number of atoms are same as left hand side and right hand side. This kind of equations are called balanced chemical equation. And why we need to balance? Because according to law of conservation of mass, number of atoms used in a reactant side should be equals to number of atoms produced in the product side, okay. So here we need to balance a skeletal chemical equation. Word equation is called skeletal equation. Now here magnesium ribbon, we have burned element in presence of oxygen gives magnesium oxide. That complete process can be described in just one sentence here in a skeletal equation. If we further write this in form of formulae, it will be further condensed form. So that will be the better option. Let's see how it works. Now balancing chemical equation step by step, the word equation is given. Zinc plus sulfuric acid gives zinc sulfate plus hydrogen. Okay, so when zinc and sulfuric acid are combining, you are getting zinc sulfate and hydrogen. Now see, zinc symbol for zinc is Zn, sulfuric acid symbol is H2SO4. Zinc sulfate, what is the symbol for zinc sulfate? Formula zinc ZnSO4, and hydrogen symbol is H2. So if we write further condensed form, this is a word skeletal equation, this is the formula equation. Now if we have to see this equation is balanced or not. Balanced or not means each atom by atom we have to see, left hand side as well as right hand side. Left hand side are called reactants, right hand side are called products. Now let us make a tabular form and write down first what are the elements are there in reactant side as well as product side. So there are 4 elements: zinc, hydrogen, sulfur and oxygen. You can see here zinc, hydrogen, sulfur and oxygen. Now left hand side, number of atoms in reactant. How many zinc are present? 1. How many hydrogen are there? There are H2, 2 hydrogen. Sulfur, there is 1 sulfur atom, and oxygen there are O4. So there are 4 oxygen atom are present. We have written the count. Now right hand side we will see how many zinc atoms are 1, how many hydrogen atoms are H2, and how many sulfur atoms are 1, and how many oxygen atoms are 4. Okay, so total this is the count for zinc, hydrogen, sulfur and oxygen. Now by seeing the count we can observe it, the reaction is balanced or not. Any number is not matching or not balancing from left hand side to right hand side, which is not equal, unequal number, we have to balance it. Now see, zinc 1 this side and 1 this side, so zinc is balanced. Sulfur 1 this side, 1 this side, sulfur is also balanced. Next hydrogen, hydrogen is H2 here, H2 here, so hydrogen is also balanced. Oxygen O4 and O4, so oxygen is also balanced. So what can be our conclusion? Equation is balanced. Okay, this equation is completely balanced. Next we are seeing another equation is given to us, that is Fe plus H2O gives Fe3O4 plus H2. We have to balance this equation. Let's learn step by step. So in first step what we should do to balance the equation? We have to first draw the boxes of each entity. Okay, so first draw boxes around each formula, each entity. After that, do not change anything inside the box. Inside the box, any formulae we should not change. We should not make any changes. In that, whatever existing, only by the number of atoms, by the suitably multiplying that number, given number, we have to balance left hand side and right hand side. So the first step is we have put all the 4 entities in a box. Okay. Now inside the box we will not make any changes. Now what is the second step? Second step, we will make a table first. Left hand side, right hand side, each atoms. How many atoms are present? There are total only 3 atoms: iron, hydrogen, oxygen. Left hand side, 1 iron. How many hydrogen? 2 hydrogen and 1 oxygen is present. We have written. Then right hand side, how many iron are present? 3. How many hydrogens are present? 2. And how many oxygen? 4. Now we can see the number is not balanced. We can see left hand side 1 iron, right hand side there are 3. It's not same as left and right hand side. So we need to balance this equation. First we will find out what are the elements, we have to balance it. What are the elements are unequal, that should be made to equal, left hand side and right hand side. We can see here hydrogen number is only equal, but oxygen is also unequal, iron is also unequal. So let's check here. Now we will start the step 3. Now here First we have seen maximum number of atoms. How we should start? We should see first whichever entity has maximum number of atoms, start balancing from that. It can be reactant side or product side, no problem. So in this complete equation, maximum number of atoms are present with this entity Fe3O4, iron also 3 and oxygen also 4. So we will start from that entity. So what we will do, it may be reactant side or product side. So let's select Fe3O4. Now what is there? There is one table we will make just to find out what we have to balance. We have to plan a strategy. What is our strategy? Amounts of now atoms of oxygen. In this Fe3O4 there is oxygen also. We have to balance first. So initially how much is present and finally what has to be balanced. So initially how much is present? Reactant side oxygen. How many oxygen are there? Reactant side there is one oxygen, okay, which is present in water, H2O. Product side there are 4 oxygen, Fe3O4. So to balance this, what we will do, we will cross multiply. We will 1 into 4 here and 4 into 1 there, okay. So 1 into 4 when we do, what will be our conclusion will be, we have done 4 H2O. So oxygen is balanced both the side. Now here 4 H2O and here O4. So oxygen is balanced, okay. One by one each atom cannot be taken. Now we cannot alter any formula, okay. Remember that we cannot alter any formula inside the box. Like if we have to do 4 H2O only can be done. We cannot write it here as H2O 4, okay. That cannot be written. If we write this, what will happen? H2 4 to the 8 and O4. So that will be, actually it will be H8O4. It is not same as this, okay. So we cannot alter any formula, or we should not be making any changes inside the box. We should do it only with the given box. Outside we can write a number and multiply by a suitable number, okay. Now let's see next step. What is the step 4? Step 4, we have balanced oxygen. Now we have, let us take hydrogen. Hydrogen, initially how much hydrogen was there? There were 4 H2O. 4 H2O, 4 to the 8 hydrogen is present, okay. Reactant side. Product side there is only 2 hydrogens are present, H2, okay. So to balance, what we should do? We should have reactant side to balance 8 hydrogen and product side cross multiply it. We are doing 2 into 4. So to make it 8, okay. So total what we have done, Fe, previous step we have done 4 H2O, this is previous step, then Fe3O4. Now hydrogen is also balanced, 4 H2, 4 to the 8 hydrogen is present. Now what is the next step? Step 5, we have balanced hydrogen, we have balanced oxygen. Again we have to go back every time after balancing any one atom, and if there is a disbalance we have to try to rectify it, okay. So now iron is remaining. So atoms of iron, initially how many iron atoms are there left hand side? 1. How many product side? Fe3, 3 iron atoms are there. So cross multiply this 3 into 1 and this 1 into 3, like this. So what will be the next step here? 3 Fe. So now iron is balanced. This iron was not balanced, which is balanced. Right hand side Fe3 is there, left hand side there is only Fe. So multiply by 3, we can balance it by cross multiplication, okay. So what all the atoms we have balanced till now? Oxygen, hydrogen, iron. Now check the balance equation. After balancing we have to, every time again we have to revisit the equation. What happens when we try to balance one atom? We multiply by some number, then what happens? Another atom which is present in that formula will be getting disturbed or unbalanced. So we have to keep checking it after every step. Now check the balance equation, count the number of atoms. After that, what is the equation we are getting? This is the balanced chemical equation. So we could balance it step by step. First we have balanced oxygen, then we balance hydrogen, then we balance iron, okay. Like this, 3 Fe plus 4 H2O gives Fe3O4 plus 4 H2. Now we have to write in parenthesis. Parenthesis means in the bracket, in subscript we have to write a physical state. Writing that is very important, because physical state is only making us how the reactions will take place. To understand the reaction we should write a physical state. So Fe in a solid state we are writing, see, solid, liquid and gas will be written with these symbols, S for solid, L for liquid and G for gas. Apart from that, two more symbols will be there. If we are talking about a precipitate, so arrow will be downwards. Why? Because solid particles will settle at the bottom of the test tube or any instrument or apparatus which we are using. So always precipitate will be written with the downward arrow. Any gas is liberating, that will be written always with the upward arrow. Okay, so upward arrow indicates the substance is in gaseous form, which is liberating the gaseous form. Okay, why? Because interparticle force of attraction in gaseous molecule is very less. Molecules will try to go up first because of the light mass, as well as their interparticle attraction is very low. That is why. So now we will write Fe is solid, water is in gaseous state here, water vapors, Fe3O4 also in solid state, and hydrogen is in gaseous state. So we can indicate with the arrow upwards, which is showing there is hydrogen gas liberated as a side product. Okay, so this is a balanced chemical equation, and when we balance it, first what are the quick revision I will give. Whatever equation, skeletal equation is there, word equation, we will try to write formulae. Second step, we will write a formula. After writing formula, we will put each entity in one box. Inside the box, we are not making any changes. Then atom by atom, initial and final, what all the changes has to be done, reactant side to product side, we will observe. After every observation, after every changes, we have to cross check the equation again, count the number of atoms again, and at the last we are writing the physical states in the parenthesis. Okay, so when physical states are written, specific arrow has been given, reaction is completely balanced, it is ready. Next we will see, like this is the equation which we have balanced it. Similarly, where it plays an important role, now we can see carbon monoxide reacts with hydrogen. On the arrow also the conditions will be written in a reaction, balanced chemical reaction. So what are the conditions which we are using here? Specific atmospheric pressure will be used, 340 atmosphere. So that's what it has to be mentioned on the arrow. If we are using any temperature, any catalyst, everything should be mentioned on the arrow. And methanol will form. Then if we have 6CO2 plus 12H2O, this is photosynthesis. What is the photosynthesis process? From the chlorophyll, carbon dioxide, with the help of chlorophyll, carbon dioxide and water, in presence of carbon dioxide and water, photons of sunlight will be absorbed, and when the reaction happens, it will give large amount of energy in the form of glucose. The food is prepared, oxygen is liberated, and water vapors are also present. So this is a photosynthesis process. Photosynthesis process, photo word is used for photons of light, which is taken from sunlight. Synthesis, what they are synthesizing? Plants are preparing food. We can give in simple language, plants are preparing food using the method called photosynthesis. So the green pigment present in the leaves is called chlorophyll. That chlorophyll is helping trapping carbon dioxide and water and photons of light. In presence of that, we are getting glucose as a food prepared, and which is the source of energy also, and that is only making plant to survive further. Okay, so all part of plants will grow, like branches, leaves, flowering, fruiting, everything will be happening by this process. So when this process is there, plant will be alive and the process will continue. Otherwise, if this process is not there, suppose you stop watering a plant, what will happen? If the natural process is also not there, natural water is also not coming to that place where the plant is kept, and you are also not providing any water, so plant will die. It will get completely dried up. So that is why all this required thing is sunlight is required, water is required, carbon dioxide is required, as well as chlorophyll should be present in the leaves. Okay, then this kind of few example is there, like in your books only examples are there. If the skeletal equation is there given, hydrogen plus chlorine gives hydrochloric acid. So write a equation. If we write, hydrogen is written as H2, chlorine is written as Cl2, hydrogen chloride is written as HCl. So let's balance. Now left hand side, how many hydrogens are present? 2. Right hand side, there is only 1 hydrogen. So let us put 2 here. So let us see if it is getting balanced. So hydrogen is balanced, H2 and 2H. Now in this process, Cl also should be balanced. So left hand side, Cl is 2. Right hand side, 2 into Cl is also 2. So this equation we can say it is completely balanced. Okay. Next equation we can take sodium hydroxide plus HCl gives hydrochloric acid, gives sodium chloride and water. So first you see Na, left hand side Na1, right hand side also 1 Na. Then oxygen we are taking, left hand side 1 oxygen, right hand side also 1 oxygen. Then hydrogen, left hand side how many hydrogen? 2 hydrogens are there, here H2 is there. So hydrogen is also balanced. What is the remaining now? Element is remaining is chlorine. Left hand side there is 1 chlorine, right hand side is also 1 chlorine. So this equation does not require any balancing. This is already balanced equation. Okay, so there are few reactions, while writing only they are already balanced. There are few reactions which are not balanced. So according to law of conservation of mass, number of elements or number of particles used in left hand side, reactant side should be equals to number of particles produced or as a form of product on right hand side should be equal. Okay, that's why we are balancing the equation. So